Hello, my name is Jansson and I will talk about my project, which is about temperature-controlled curtains. The idea came from the fact that my apartment gets really hot during the days, which is partially because of the sunlight that shines through my windows pretty much all day long. I've been preventing this by closing the curtains. However, I like the natural light, but I just can't stand it when it gets too hot. And this is where the project comes in. Automating the curtains gives the optimal amount of natural light, but only when it's not too hot inside. How it works? Well, basically, I have done a string contraption made with fishing line that I have attached to the curtains. So pulling one of the lines would open the curtains and the other line would close them again. With this contraption, I have installed my PyCom device together with a temperature sensor and a motor. The PyCom would get the temperature data. It would check the temperature. If it's too high, the curtains would close, and if it's lower, the curtains would open. The data would then be stored in a database and later sent to a website for visualization. And there it would display things like statistics and some average calculations, etc. So this is how the string contraption works. As you can see in the first image, the red arrow represents the fishing line. The line is attached in this area, and if you pull it in this direction, the curtains would open. Now in the second image, we can see that it is attached in the same area, but when it's pulled, it will go this way and rotate around here. And they go the same way as the first line. This is important because I only want to use one motor, and this makes it possible for that motor to switch curtain state just by swapping directions. These are the PyCom schematics. Here I have 5 sections. The first part is the PySense development board, together with the LiPo battery as the power source. This has been very useful to power my project and to upload code and experiment. Secondly, there is the temperature sensor. This just measures the temperature in the room. Then we have the motor and a 9-volt battery. This battery is necessary for the motor to be strong enough to carry the curtains back and forth. Then there is the door switch. This just consists of 2 wires that leads to my balcony door. And when the door is closed, it will short the wires and send a signal to the PyCom. This part only exists because I want the additional data. It has no real-world functionality actually. And last we have the manual button. Since the PyCom device will only run for about one time each 20 minutes, this button will make it possible to open or close the curtains manually, no matter the indoor temperature and whenever I want to. This is especially useful during the night when I want to have the curtains closed. If you're observant, you might notice the Arduino in the lower image. However, it is not used in the project. It just so happened that I didn't have another free breadboard than this one. The Arduino is not connected to the project at all. In that picture, we can see that the circuit is very messy. It's hard to tell what's going on, so I thought that some soldering would really help. So that's what I did. As we can see here, after soldering, we can actually see that it's a big difference in how messy it is. I mean, we can even see that we have the temperature sensor here, the manual button that goes here, and these white wires are the door switch, and as we can see, we have the Pisons and the motor. So everything is actually visible right now. This makes it a lot cleaner and also easier to handle. The wires will not get dislodged quite as easily anymore either, and that brings down the risk of unintentional shorts as well. However, since the motor needs something to keep it steady while working, I thought of creating a casing of some sort. What I did was I found an old phone box that I got previously, and it was actually kind of perfect because the box was very sturdy and it can handle the screws for the motor without any issues. As you can see here, the screws fit in there pretty well. If it was a normal cardboard box, I would suspect that it would get worn down pretty quickly from the force of the motor, or actually just the force of the screws. And in the first image here, we can actually see the 3D printed spool for the motor. This is where the line would be attached. I actually had help from a TA to print and send this, which was extremely helpful. And as we can see here in the second image, the inside looks like complete chaos, but it's actually fitting better than it looks, I promise. If you look closely, you can see that the 9-volt battery is actually put in a static-proof bag to avoid shorts, and the circuit board that I soldered as well has a static-proof bag taped to the underside of it, just to avoid damaging my device. And in the third image, we can see that I have carved out a little piece here in the front so the motor can fit, and a little piece here on the right so the cables can get out of the box. Now onto the data. The temperature is actually read about 5 times each second for 20 seconds. That's a total of 100 iterations. All of this is done to get an as accurate temperature reading as possible, because if I would then calculate the average of all those 100 data points, I will get a very accurate result. Not only that, but I also record the highest and lowest value to get the difference between them, or the margin of error of all my data readings. And if the margin of error would be more than 2 degrees, I wouldn't accept the results and I would have to restart the data gathering phase. Now, time is important for the statistics. To know when a time reading was read is crucial for the visualization to work properly. This is gathered by synchronizing the RTC, or the real-time clock, in the microcontroller, and this can luckily be done through Wi-Fi, which conveniently is my wireless protocol of choice as well. And last of all, we have the door and curtain status, which is sent as 2 different Boolean values, that is true or false. The door is simply read through the door switch. The curtains, however, needs no physical check. This is because the PyCom stores the curtain status from earlier in its internal memory. So all I had to do was to tell it what the status was when I first installed it. And from there it will always know the status. Since the PyCom is what controls the curtains to 100%, it will know that the curtain states depending on the last action. This means, however, that I can't physically change the state of the curtains by hand anymore. Which then again proves why a manual button is so important in case I want to open and close them whenever I want. And then all of this data is then formatted by the PyCom and the data transfer phase will begin. So this is the data transfer route. It starts at the PyCom, which has the formatted strings with temperature, door status, curtain status, time and date, and all of that good stuff. Then it sends that data through a Node-RED server, which then again formats the string into an object suitable for the database, which in this case is a MongoDB cloud database. And later, when we want to access the website for visualization, we will get the data from MongoDB with the help of some backend Node.js in JSON format. That data can then be used however we want for stuff like calculations, visualization with diagrams, seeing correlations between door status and temperature, and a lot of other stuff as well. So these are the visualizing results. These are diagrams made with a tool called Google Charts. This particular one displays all the daily data readings, and we can also see the daily maximum and minimum marked in the diagram as well. And below the diagram there are some statistics down here, where we also can see the daily maximum and minimum together with the timestamps. And as you can see, these timestamps fit pretty well with the chart as well. There is also a daily average that is calculated by using one data point by each and every hour, and then getting the average value out of all of them. That one data point in each hour is calculated by getting the average value in that hour. This is all to make sure the calculations become accurate. Since sometimes there might be more data readings 1 hour than the other because of the manual switch. I could theoretically switch the curtains 15 times 1 hour if I wanted to, and that would really mess with the daily average, especially if I did it during a bad time during the day. However, we can also see the temperature records here in the bottom, from the lowest temperature ever and the highest temperature ever, from this project's start, of course. This is also actually a public website that you could visit yourself at this link. This was a personal choice to have it public, and I could have made it into a private site if I wanted to, but I made it public since I like to share what I create, basically. As you can see here, the mode is changed into door status instead. Now the maximum and minimum values are not displayed in the chart anymore. Instead we can see an area chart that is marked orange when the balcony door is closed, and blue when the door is opened. This finally makes sense now, since we can see that the temperature drops drastically during the time the door is opened, and that would be a very weird data reading if we didn't have this information. And lastly, here we can see an area chart with the curtain status instead, which shows that the curtains are closed on the blue line and opened on the green line. This is a simple explanation of some additional functionality of the project. There are 3 different colored areas in this chart. This is nothing that is available, this is just an image for this specific explanation. And as we can see, the white area says that if a data reading would be anywhere here, the motor won't move. So for example, before 8 AM here or after 10 PM, it doesn't make much sense to move the curtains depending on the temperature anymore, because the sunlight is not even a factor at that time. So the motor won't move depending on the temperature during those hours. So the green lines here and here represent the time limit, while the red line represents the upper temperature limit, and the blue line represents the lower temperature limit. So if a data reading would be put in the blue area here, it would open the curtains, and if a data point would be placed in the red area, it would close them. There is also some additional security added to this. Since I don't want it to be public access to know when my balcony door is opened at any time of the day, I have with the Node.js tool told it to delete all the door status data that's less than 12 hours old. This would just be displayed as the door being closed and updated later. So yes. And finally, these are the physical results of the project. It was initially planned to have the box on the floor right below where it is right now. So just right down here somewhere. And the reason I had to put it up there was because the motor was too weak to handle this extra curve with a line. The line is actually impossible to see right now, the fishing line. It's attached somewhere here and here as well in these 2 different curtains. So it couldn't handle the extra resistance from the curve this would break. And the reason I actually wanted it down on the floor was because I thought it would be more discreet, and also the reason I chose to have a black wire as the manual button. This is the manual button. This wouldn't be as visible if it came from the floor and just attached to the lamp, but now it has to go through the white wall first, so it's very visible. So yeah, same with the white wire, which is not too bad at all, but it wouldn't be visible at all if it was along the floor. Yes, the temperature wire is not visible in this case because it's just taped to the back of the box. So it's pretty much invisible either way. And afterthoughts. Well, temperature is a funny thing. It's been really hard to set a constant temperature to decide when the curtains should open or close. Sometimes 25 degrees feel like 30 and above, while other times 30 degrees might be manageable. So I've been changing that a lot during the time I've been working on this project. Also, a stronger motor would be preferred. That would allow the box to be on the floor, where it would be more discreet, and also possibly open and close the curtains faster if the motor was stronger. Lastly, the website could also display more statistics like weekly or even monthly averages, maybe add more diagrams to show weekly temperatures. I mean, visualization have the most room for additional features, which is actually the reason why I chose the 100% control option, to be fair. So this has been an incredible course. I felt like I could have kept on working quite a while if I had the time. And I would absolutely recommend this course to other students as well. So that's it. Thank you and goodbye.